Alright, in probability there are permutations. That's what we just did in 11.1 and 2 notes, all about permutations. But then there's something called combination problems. And sometimes it's difficult to tell them apart. Permutations are really easy, right? Okay, combinations are too. The only hard part is telling what's the difference between the two. So here's an easy way to remember. Doesn't permutation sound a lot complicated than combination? Yes, okay. And it is. With permutations, every little detail matters. So Alice, Bob, and Charlie is different from Charlie, Bob, and Alice. So order matters in permutations. Combinations are pretty easy going. The details don't matter. You could list Alice, Bob, and Charlie is the same as Charlie, Bob, and Alice. So order doesn't matter with combinations. Okay? And let me grab this. So the first one is going to be permutations are for list. That's when you'll use permutations, when order matters. And you're going to use combinations when order doesn't matter. And I put a joke in there. It's not very funny to y'all, I don't guess, but it'll help you remember the difference. A combination lock should really be called a permutation lock because the order you put it in matters. Think about like a locker combination. If your locker combination was 10, 17, 23, and you put 23, 17, 10, would it work? No, because order matters, right? That's true. That's a math joke. It wasn't really funny to y'all. Okay, so all we're going to do for 1 through 3 is read them, decide whether you think it would be a permutation or combination, and then if it's a permutation, we know how to work it out, right? So we can go ahead and work it out. But if it's combination, we'll leave it till tomorrow. Okay? So, Georgia, if you'll read number 1 for me right here. This number 1 right here. Sorry, go ahead.
6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes president. The second most votes gets vice, and the third most votes becomes treasurer.
Okay, so let's think about this. Does order matter in this situation?
No.
Yes.
It does because you have first, second, and third, and doesn't it say the one with the most votes gets first? So the one with the most votes couldn't get third, right? Order does matter in this case. So it's a what? Permutation. Good. Right, permutation underneath. And we'll come back to number 1 because we know how to work it. So we'll talk about how to work that one in a second. Any questions about that one? How order matters? All right, Heidi, read number 2 for me.
6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study possibility of expanding the park.
All right, what do y'all think? Why?
Not a specific order.
Yes, the 3 people, does it have to be in a specific order? Is one higher than the other one? No, so this one is a combination. Very good. All right, Justin, if you'll read number 3 for me.
Baskin-Robbins offers 31 different flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor.
Which one?
Permutation.
What do we think?
Combination, because an order doesn't matter.
Are we sure?
You can have any flavors, it's 3.
Good. Doesn't matter the order of the ice cream, right? It's all going to get mixed together anyways. So does that make sense how to tell the difference between permutation and combination? Yes? Okay, let's go ahead and finish number 1 then since we know how to work it. Alright, 6 different people are running for student government president. And out of those 6 students, 3 of them are going to win, correct? So this is going to be, what formula are we going to use for this one?
N factorial.
N factorial over?
N minus R.
Perfect. What's our N?
6.
Very good. What's our R? Alright, whoever can tell me the correct answer first.
120.
Good. That's correct. 120. Can get to draw the box. Any questions about that? Alright, y'all can pack up. We will start this. We'll finish this tomorrow. Good job, man.